So we're going to introduce something called Pascal's law, and we're going to introduce it in kind of an interesting, I think, way. We're going to talk about lifting a car with hydraulics. So imagine you've got some machine over here that's going to push a piston. So there's fluid under the machine. It's going to be in a small tank. And then you have a fairly big piston or a set of pistons with a large area. So we'll call this A1 and A2. And this side is going to push your car. Pascal's law says that if we change the pressure somewhere in the fluid, we change it everywhere in the fluid instantly. So pressure changes everywhere at once. Now, this is an approximation, is that if you had a big enough fluid, your pressure change would vary by the speed of sound in the fluid, or even, up to a limit of the speed of light. You make enough space and then this fails apart. But for something like a piping system, like hydraulics, it works. Now, let's say we apply some force here, F. Well, what it's going to do is change the position of this piston, delta X. So the work done is F1 delta X1. Now, what it has to do is also move this piston. So there'll be some force upwards, F2, and some change in position, delta X2. So F1 delta X1 equals F2 delta X2. All right, the work that we put in without any losses should result in the work out on the other side. So this force times distance equals force times distance. But we can write the force in terms of the pressure times the area times delta X1 equals the pressure times the area times delta X2. Sorry, that's 1. So we can write it in terms of that. And then we can go and say, well, the pressure can't really change. What we're talking about is a change in pressure here, and delta P1 is delta P2. So what this means is that the area times delta X1 equals the area times delta X2. And eventually, so what this is saying, this is what's called continuity. Which is saying the volume that moves, the volume of fluid that moves here has to equal the volume of fluid that moves there. All right, so if we move a long, like a drinking straw's worth of fluid here, you'll have a very shallow amount of fluid. Say that amount is how much moves on that side. It results in a fairly big amount on the other side moving because they're different areas. So we can rearrange this one more time and note that that X1 here is really the work divided by the force. And I'm going to rearrange it. So this is Pascal's law. Is that the force divided by the area has to be the force divided by the area there. And that's just saying that the pressure changes are constant. This is saying that statement. So anytime you have a problem where you have basically two pistons moving, one moving down, one moving up, this is what's going on. Where you have a fluid, it's flowing, but we're not considering the speed of the stuff moving. We're just considering that it moved and then it stopped again. All right, so let me pause the video again and see if I can't show this to you. All right, so let me explain what I've got here. So I've got, I went to the farm supply store. I think I bought these at Tractor Supply, but nowadays I'd go to Rural King. Just not an endorsement of any particular store, it's just, what's available where I drive. And I bought 2 farm syringes. One is 60 milliliters, So it has a nice printed scale on it, or 2 ounces. And the other one, which I can't show you right now because it's full of liquid, so is 3 milliliters. Right. And they're connected by a hose, which now is full of inky water and a little bit of air because I've squirted some air in it. But let me show you. Right, there's the area of each of these cylinders. Let's raise this up a little bit. There's the area of each of those cylinders. All right, and you can tell one's small and one's big. And so if I push the big cylinder a little bit, right, I'm going to hold it here so you can see based on how far the big cylinder moves. Come on. Takes a little bit of leverage. Let's pull on the small cylinder. There we go. You can see I'm not moving the big cylinder very much to get the small cylinder to move a lot. And this is the idea of a car lift, is we'll have our stand-in car, if I can find something like that. There's our car. And if we want to move it, we take a small cylinder and we move it a lot, and we cause the big cylinder to move a little bit. So there we go. So I'm going to shrink this down a lot and see how much how much the big tube moves. Not that much. And then we can undo it. And that's what's happening here, is we're doing a certain amount of work. This tube is easy. It's very easy to move it. But you have to move it a long way to do a certain amount of work. And then this is, we can count about 7 of these lines are what we end up moving it for. So when we push that much fluid out, all right, my video kind of stuck for some reason. That's weird. Why did it do that?